My research topic is the impact of vaccinate rates on new mortality rates during the global COVID-19 pandemic. The data I selected is from our World in Data, which covers the COVID-19 pandemic in countries around the world from 2021 to 2022. I asked a total of 4 questions. Is there an overall clear relationship between vaccinate rates and mortality rates? Are there differences in this relationship between different continents? What is the difference between fully vaccinated and partially vaccinated? Has the effectiveness of vaccination changed from year to year, 2021 versus 2022? This answer focuses on a key question: whether the association between vaccination rates and COVID-19 deaths varies significantly across regions. The aim of the study is to understand, is the impact of vaccination on COVID-19 mortality consistent across continents? Where are the vaccines more effective? We plot scatter plots and regression lines of vaccination rates and new deaths across continents. We first see that Asia vaccination rates have a weak negative correlation with deaths, and in Europe there is a clear negative correlation with higher vaccination rates and significantly lower deaths. Africa, there was little to no correlation, suggesting that the vaccine effectiveness was limited by other factors. And we can see the North America and South America both showed a significant negative correlation, and the effect was more obvious in South America. We can see the Oceania showing a weak positive correlation. Special cases warrant further study. Overall, there are clear differences in the impact of vaccination on mortality between continents. And we can, through the linear regression analysis of OLS done separately for each continent, we have more specific conclusions. Vaccines in Europe and South America are the most effective, indicating that vaccines have a clear role in controlling mortality. Vaccine effects in Asia and North America is weaker, suggesting that there may be interference from other factors. The correlation between vaccination and death is almost non-existent in Africa, possibly due to low vaccination rates or inadequate medical facilities. And a weak positive correlation in Oceania may be affected by a small number of national samples or individuals' extremes. To further statistically verify the significance of regional differences, we performed ANOVA. The results of the ANOVA test show statistically significant differences in new COVID-19 mortality rates across continents. We then performed the Tukey HSD post-event test. There are significant differences between Africa and Europe, North America and South America, indicating that the new mortality rate in Africa is significantly lower than that in Europe, America and South America. There are also significant differences between Asia and Europe, South America and North America, with Asia having significantly lower no mortality rates than Europe and South America. Oceania also shows significant differences from South America, North America, and Europe. The aim of this study was to explore whether vaccination status globally between 2021 and 2022 was significantly associated with the number of new deaths due to COVID-19. First, we imported the globally published COVID-19 dataset, and we selected the key variables required for study: new deaths per million and people vaccinated per 100. And missing data were clean, and the time frame of the study was screened to ensure the quality of the data and the reliability of the analysis. And let's take a look at the distribution of the data in the following graphs. First is the histogram of vaccination rate distribution. There is a clear bimodal distribution, indicating that there are significant differences in vaccination levels across countries or regions around the world. And vaccination rates are close to zero in some countries, reflecting the uneven distribution of resources. And then the histogram of the distribution of new deaths. The vast majority of new mortality rates are close to zero, and a few countries or regions have extremely high values, suggesting that there may be an impact of extreme values in our analysis. And then is a histogram of the number of data records by continent. Europe and Asia have the largest amount of data, while Africa and Oceania have less data, which also reflects the differences in data collection. And the core part of this study is to explore the correlation between the two through scatter plots. And we can see the scatter plot shows countries with higher vaccination rates uh, have lower overall new mortality rates, suggesting a tentative hint at the effectiveness of vaccines in controlling mortality. The results of a univariate linear regression analysis. And we can see the, the regression con, coefficient, coefficient was significantly less than zero, indicating that for every 1% increase in vaccination rate, the average new mortality rate decreased by 0.02 people million. Although the overall R-squared value is low, indicating that the vaccination rate has relatively weak explanatory power for mortality and may be greatly influenced by other factors. In this section, we look at whether the protective effect of vaccines varies with different stages of the pandemic. Is there a significant difference in the effect of vaccination on mortality reduction in 2021, early in the pandemic, just in the vaccine rollout, and 2022 in the later stages of the pandemic, when the vaccine is widely available? We set up linear regression models for 2021 and 2022. We can see the 2021 regression analysis. The results of the model showed that the vaccination rate had a significant negative correlation effect on the reduction of deaths, and the regression coefficient was very low, and the significance was extremely high. Although the overall explanatory power was weak, R squared equal 0.0003. The coefficient significantly indicated that the vaccine was indeed effective in reducing mortality in the early rollout phase. And we can see the 2022 regression analysis. In stark contrast to 2021, the coefficient for vaccination coverage in 2022 was 0.0038, almost close to zero and not significant. This suggests that the protective effect of vaccines in 2022 may be affected by virus mutations, increased vaccine coverage, or other factors. In order to more definitively verify whether vaccine protection changes over time, we innovatively introduced interaction item analysis. And interaction analysis results, we contrasted the interaction term between vaccination rate and the year 2021 and 2022, and the results show that the effect of the vaccine is not static, but changes with the stage of the epidemic, virus mutation, and other factors. The protective effect of vaccines in 2021 was significantly higher than that in 2022, and there were phased differences in vaccine effects. And we analyze the monthly trend changes in global vaccination rate and mortality rate between 2021 and 2022 through intuitive visualization. And we can see the first histogram trend chart of vaccination rates, a clear S-shaped curve from the low from a low level of rapid growth at the beginning of 2021 to a flat in 2022. Vaccinations are gradually entering the saturation phase, and we can see the new mortality trend chart. Mortality rates have been declining gradually, but not at a constant pace. The rapid decline in mortality in the first half of 2021 may be mainly due to the apparent initial effect of the vaccine rollout. In the later period of 2022, the mortality rate was relatively stable and even occasionally fluctuated and increased, which is closely related to the decline of vaccine protection and the emergence of virus mutations. And in this analysis, we focused on the difference in the effectiveness of COVID-19 vaccine coverage in reducing mortality between 40 and partially vaccinated rates, and explored the specific impact of high and low vaccination rates on the number of deaths. First, when using heat map analysis, we found a high correlation between 40 vaccinated and partially vaccinated rates, indicating that the trend of 40 and partially vaccinated people was constant in most regions. The correlation with mortality was low but negative, implying that there was a slight downward trend towards mortality with higher vaccination rates. And then a scatter plot of partial vaccination showed that the mortality data fluctuated, influenced more significantly when the vaccination rate was lower, and the extreme mortality value gradually decreased with the increase of partial vaccination rate. And then the scatter plot of 40 vaccinated people also shows that the higher the vaccination rate, the lower the extreme value of the number of deaths, but the overall trend is more pronounced, suggesting that the protective effect of 40 vaccinated may be better than that of partial vaccination. and um, we also use multiply linear regression methods to analyze the effects of both complete and partial vaccination. The R-squared value of the regression model was 0.004, suggesting that the vaccination rates as a whole explain only a small part of the change in mortality, and that there may be the other more important influencing factors. There was a significant negative correlation between the rate of full vaccination, with each percentage increase in the rate of complete vaccination decreasing the number of days by about 0.019 per million, while the partial vaccination rate was not statistically significant. And then we innovatively used the stratified analysis, low, medium, and high groups of vaccination rates to dig deeper. It was found that countries with higher vaccination rates had lower mortality rates. The average number of deaths in countries with low vaccination rate was 2.83 per million. The vaccination rate in the country is 2.01 people million. In countries with high vaccination rates, it's only 1.3 people per million. Box plots illustrate this trend visually, with a significant reduction in the extreme deaths in countries with high vaccination rates.